Well, we're showing how to make a very inexpensive conversion by removing the carburetor and letting the engine breathe without restriction all the air it can get on intake, so it'll have more air in the compression stroke and more air available for burning more fuel.
Now this is the 5 horsepower John Deere we were looking at earlier.
It is. It's shown now in the least expensive conversion mode, just using a delivery tube to bring the hydrogen right to the intake valve port. We're doing the control and thus the engine power control with a metering valve, which is a needle type valve, and it's common to the instrumentation industry where it would be used for controlling the flow of nitrogen or oxygen or hydrogen in a lab. But it's sized for delivery on an 1/8 inch tube. We then cut it down to a even smaller diameter at the point of injecting.
This is about a 16th inch down here?
Well, it's about a 16th inch at the point of entry. But you can well do with even a smaller orifice, and I brought one that's for such engines as this, and you can see it as
we're going to zoom in on this real carefully.
As an example of the size of orifice we'd use for delivering the hydrogen at the intake port on a very inexpensive conversion.
So this is the size that you'd like to deliver through?
It's about the right size. Now you can come all the way over here with a 1/4 inch tube, make that final delivery just at this location on this
so we can come over here
orifice.
with a 1/4 inch tube, what we have available, and then deliver through this small orifice or any other small orifice.
And you'll notice it resembles a type of hypodermic that would be used around a veterinarian supply. So you might think of picking one up from a veterinarian supply, or you might even pick up a bicycle, or I should say a basketball fill port.
But that's just a narrow tube. What's the outside and inside diameter of that approximately?
Well, it's about a 1/16 of an inch.
Internal?
Internal.
Okay.
So what else we're showing is the ability to run this on a basis of setting up one valve, that is the idle valve, and then you can set up a valve in parallel that gives you the ability to put this on a remote, on a foot feed, so that you'd set up the idle RPM at, say, 1,000 RPM.
So basically we're going to run hydrogen through this valve, which is the fine control needle valve.
That's right.
And that's going to be for our idle speed, where it's just enough to keep the engine spinning and spinning and spinning.
True.
And then when you hit this one, which is a full feed valve.
It is. This is a full feed valve.
But it's variable too. You can control it.
It's all the way from idle or off,
right,
where this is carrying the fuel, to much larger flow, maybe 10 times as much flow for acceleration and high-speed running.
So if you open this all the way up, it's going to go vroom in wide open throttle.
It does. And that way, I'm just saying that you could put this on the foot feed, use this as a stationary...
Foot feed. Foot feed. You mean you're going to control this right here?
That's right.
With your foot?
That's right.
Well, that moves pretty hard. I mean...
Well, you just put that through a cable. You'll notice this one's equipped with a stop pin. You can probably focus right down on that stop pin.
Yeah, hang on, hold it up. Here we go.
When the pin's in place, you can't take it to full open. You take it to almost full open, but it always comes back. So that makes a very handy way to just put a lever to your foot feed position. And so the foot feed will still have mechanical advantage, and that turns out to be about the right tension.
Oh, you're right. My foot has a lot of strength on it. Plus, it's on the lever of the pedal. So
that's right.
Yeah, there would be.
But in any event, you can run it with a single valve or with 2 valves, as just discussed, and still be under $25 in conversion.
Under $25 to convert this engine right here?
That is right.
But
and get more power than before.
More power.
And be able to run a fuel that you can make. The other comment that I wanted to make in this regard was that in order to arrest vibration here, I've just run a longer length of this springy stainless steel.
It's not showing up that good on the video. Here we go. I can see it now.
Yeah.
So this is the intake tube. What's this right here? This is... What's this?
That's my kill ignition.
Oh, it's your kill ignition. So this is a kill ignition wire, and this is the actual tube carrying the hydrogen right here.
That's exactly right.
And this runs all the way over
to here where I do the valving.
Oops, turn this around here. Okay, so there's the tube right there, and there's your valve. Now,
that's right.
Now this needle control valve, that would be your idle set, and you use this one to really change the speed, but you're using this one for both, aren't you?
Yeah, you can set them up so that you can do everything on a hand valve, or you can do a combination of the hand valve for idle and this type of
Oops,
acceleration.
I had the wrong one.
Yeah.
I'm sorry.
This type of acceleration.
This is the idle
That's right.
type of valve, and this is the acceleration type of valve.
That's right.
And you're doing everything, it was just that one right there.
That's right. Now, the other thing I wanted to cover in this regard is you can do your own timing off of an engine such as this one by removing the flywheel, removing the key that makes it for the gasoline setting, and then relocating that key for a later ignition. And you can then either use a half key for the offset, or some fraction thereof, or you can mill a new slot for your new setting for hydrogen.
Okay. And that's internally in the engine, though?
That's internally in the engine, but it's a quick conversion. The other alternative is to change the magneto timing electronically. You can do a delayed off for the flow of current to the coil, and run this as a Kettering type of ignition with an external coil.
So either way, you're going to have to really change your timing on the engine if you want to take full advantage of the hydrogen.
You'll time to a later point of ignition.
Pretty close to top dead center.
Pretty close to top dead center is correct. And you'll, by doing so, save a lot of heat that would have been lost to the combustion chamber surfaces.
Who makes the ignition delay type of thing you were talking about? Instead of changing the timing in the cam that fires the spark plug, we're talking about delaying the signal from here to the spark plug with electronics.
Well, there are a number of companies that make ignition control systems, but ordinarily they make them for advancing ignition. We use it for delaying ignition. One such source is Autotronics.
Autotronics, A-U-T-O-T-R-O-N-I-C-S?
That's correct.
They're on the web?
They are. And there are others. But you can make one out of a Radio Shack sourced 555 integrated circuit.
Wouldn't performance automobile shops carry some of those parts as well?
Oh, a lot of them carry a variety of different brand name ignition control systems. These are usually, again, for engines that are burning slow, burning fuels such as gasoline or methanol.
Also, before you run your car on methanol, like if you're a top fuel dragster or a weekend dragger, you're going to have to change your timing.
You'd have to advance timing.
Okay.
But here we're making it so that we get a much higher thermal efficiency and a much greater use of the fuel, producing more power than before by making a later ignition, because we have a much faster burning fuel. Well, those are the points that I wanted to go over, Steve, and show that you can have a very inexpensive conversion.
Okay, we'll move to the next subject.
Good.
Okay, now one part I want to reinforce for the viewer. Again, exactly does the conversion of the single cylinder apply to how they're going to convert their vehicle, where it's a 3-cylinder Geo, a 1987 Dodge truck, or an old Cadillac with a carburetor, or a new vehicle? How are they going to use this to start their conversion on their vehicle?
Well, every one of the vehicles that you mentioned have a number of one-cylinder engines all put together as a V8 or put together as a 3-cylinder inline Geo, as you mentioned, or a V6 or an inline 4, whatever it may be. But here are the essential components. You make the decision on how you're going to operate the fuel storage, how you're going to operate the delivery of the fuel and metering of the fuel, more or less like we do on this one cylinder.
So this mechanism right here would control the flow to all 8, all 6, or all 4, or all 3, or all 1 cylinder.
That's right. You can make this so that it was manifolded, so that it could be the entire system. And it can be manifolded for a hand valve, or it can be manifolded for a combination, as we mentioned, of a foot-feed operated flow valve that gives then the ability of this system to do everything that is in your automobile today off of a single control for high-speed operation and a single control for idle.
Now, isn't it exactly this valve right here that is in your Geo outside that we were driving around in?
It is.
It's that valve that you were driving with all those fuels on, and it's basically this manifold right here that you were driving around on.
It is.
On that geo that we were having fun in.
Yes, it is.
That's simple.
Yes, it is.
But the timing has to be advanced.
The timing has to be not advanced, it has to be slowed to near top dead center.
Okay. So advancing the timing is going away from top dead center, and slowing the timing is going toward top dead center then.
During the compression stroke, if you slow the timing, you're moving towards top dead center. If you advance the timing, you're moving towards bottom dead center.
Okay, I got it.